For ages, the idea of a huge space rock smashing into Earth has made people really anxious. It's easy to see why. Asteroids are scary. If one hits us, it could trigger enormous tidal waves, start a new ice age, and cause a blast bigger than anything we've ever seen. While movies often show asteroids causing chaos, this danger isn't just Hollywood fiction. Asteroids are a real and serious threat to all of us. In fact, NASA has already found some giant asteroids heading straight for Earth. That's where NASA's DART mission comes in. It's the first project aimed at testing how we can deflect an asteroid that's on a collision course with Earth. So, what exactly does DART do? When will it start? And most importantly, how can it protect us from one of the biggest dangers we face? On October 22, 2021, an enormous asteroid named 2021 SM3 zoomed past Earth at incredible speeds. This giant rock, measuring about 525 feet across, is bigger than the Great Pyramid of Giza. The scariest part? Scientists only spotted it a month before it flew by. If it had been on a collision course, we wouldn't have had enough time to stop it. Earth faces many such close calls with asteroids every year, which is why NASA is working hard on a system to prevent a disastrous impact. NASA's Double Asteroid Redirection Test, DART, managed by Johns Hopkins Applied Physics Laboratory for NASA's Planetary Defense Coordination Office, was the first mission to test deflecting an asteroid by hitting it with a spacecraft. Launched on November 24, 2022, on a SpaceX Falcon 9 rocket from California, DART traveled over 10 months before crashing into the small asteroid moonlet Dimorphos. This 530-foot, 160-meter moonlet orbits a larger asteroid named Didymos. Neither asteroid threatens Earth before or after the impact. DART proved NASA can guide a spacecraft to collide with an asteroid and change its path. Equipped with the Didymos Reconnaissance and Asteroid Camera for optical navigation, Draco, and advanced navigation systems, DART identified and targeted Dimorphos, guiding the 260-pound, 570-kilogram spacecraft through 56,000 miles, 90,000 kilometers, to hit Dimorphos at 14,000 miles, 22,530 kilometers, per hour. Draco captured close-up images of Dimorphos's surface moments before impact. 15 days earlier, DART released a CubeSat, the light Italian CubeSat for imaging of asteroids, Lycia Cube, to photograph the impact and debris. The mission aims to shorten Dimorphos's orbit by a few minutes, showing that a spacecraft can autonomously navigate and collide with an asteroid. DART, small for a NASA spacecraft, has a 1-meter-wide box-like body and two 40-foot solar arrays. It uses electric propulsion, gaining speed until it heads toward Didymos. 5 days before impact, it releases a satellite to capture the event. Autonomous navigation takes over 4 hours before impact, using Draco's images to ensure a precise collision with Dimorphos. DART uses an advanced navigation system with algorithms called Small Body Maneuvering Autonomous Real-Time Navigation, or SmartNav. This technology enables DART to distinguish between Didymos and Dimorphos and target the latter accurately. All the critical navigation and adjustments will take place in the last hour before impact. Since dimorphism is about 6.8 million miles away from Earth, the mission has to be fully autonomous. After all the careful planning, the actual collision will happen in a matter of seconds. DART will hit Dimorphos, altering its orbit around Didymos from 11.9 hours to 11.8 hours, a change of just 4.2 minutes, bringing Dimorphos closer to Didymos. Once DART hits, the data will be quickly sent back to Earth for analysis by NASA's scientists. The best outcome would be a proven, effective method for diverting an asteroid on a collision course with Earth. The worst outcome would send scientists back to the drawing board. Astronomers will use Earth-based telescopes to compare data from before and after the impact to measure how much Dimorphos's orbit changed. This key measurement will show how effective DART's deflection was. The European Space Agency's HERA mission will visit Didymos and Dimorphos a few years after the impact to gather more data, giving scientists additional insights. The concept of deflecting an asteroid isn't new, but NASA has been eager to test it for a long time. They needed the right asteroid system, and this one is ideal because Dimorphos orbits Didymos at a slower speed, making it easier to measure the results of the experiment. The data gathered from the DART mission will be crucial for future planetary defense strategies. Dimorphos was selected for this mission because its size is similar to asteroids that could potentially threaten Earth. However, the twin asteroid system it belongs to poses no direct threat to our planet. Instead of destroying the asteroid, the DART spacecraft will give it a slight push to alter its path. This push will change Dimorphos's orbit around the larger asteroid Didymos. This means there's no risk of redirecting dimorphism in a way that would make it a danger to Earth. The impact will only change Dimorphos's speed by about 1%. While this seems minor, it will cause Dimorphos's orbital period to shift by over a minute in its 11-hour and 55-minute orbit around Didymos. Experts from the Johns Hopkins Applied Physics Lab predict that if the impact is successful, it will alter Dimorphos's orbit by at least 73 seconds. By measuring the momentum transfer between the DART spacecraft and Dimorphos, scientists will learn how much energy is needed to change an asteroid's path. This information is crucial. If we ever find an asteroid on a collision course with Earth, NASA will know how much force is required to deflect it. It's easy to see why this knowledge is so important for our safety. Currently, no asteroids are on a direct collision path with Earth, but there are many near-Earth asteroids of various sizes and shapes. Identifying these objects before they pose a threat is vital for planetary defense. The idea is to slightly change the asteroid's speed, which in turn changes its orbit. This small alteration ensures the asteroid won't be in the same spot when it could potentially hit Earth in the future. Although the entire mission will take a long time to complete and fully analyze, it's already making significant progress. On December 7th, 2021, the DART spacecraft opened the round door covering its Draco telescopic camera and captured its first image. The photo shows a dozen stars against the black sky, marking the intersection of the constellations Perseus, Aries, and Taurus. Countless asteroids are drifting through the vast expanse of space. There are millions out there, with thousands that could one day threaten our existence on Earth. Ultimately, what DART is attempting is the smartest and most reliable method to prevent an asteroid from crashing into our planet. While there are many dangers in deep space, DART might be the key to stopping the biggest threat of all. The success of DART is helping to advance theoretical asteroid deflection models and enabling researchers to better understand how and when a kinetic impactor spacecraft could be used to deflect an Earth-bound asteroid. However, more research is still needed to fully understand if a kinetic impactor spacecraft would be as effective in mitigating against a more solid object than rubble-pile Dimorphos that would eject less material into space upon collision by a spacecraft. Thus, we must continue to test other deflection techniques to have a varied planetary defense arsenal of response options that would best address the type of object we might have to deflect. What are your thoughts about NASA's progress on this mission? Comment your thoughts down below. If you like this video, then like, share, and subscribe. We will meet you in the next video with more interesting content on space science.